All right. So the first question of this October-November 2024 AS levels chemistry P21. So this is paper 2 variant 1 of A levels. All right, it's October number 2024. We're doing the first question. Cobalt, rhodium, and iridium are metals in the same group of the periodic table. The shortened electronic configuration of cobalt is AR3D7 4s2. Identify what is meant by AR by giving its full electronic configuration. So we want to give the electronic configuration of AR. All right. So if you look at AR in the periodic table, and the periodic table would be given in this as well. All right, just rotate it. All right. So if you look at argon, argon has 18 electrons. So the electronic configuration of argon itself is basically what the shortened electronic configuration or the AR actually means. So all we have to do is we have to write down the electronic configuration of argon over here. All right. So we want to write down the electronic configuration of argon. So for 18 electrons, it should be 1s2, 2s2, 2p6, that is 10 electrons, 3s2, that is 12 electrons, 3p6, that is 18 complete electrons. This is meant by AR over here. All right, this is meant by AR over here. Okay. Next question. The lowest energy electrons in cobalt are in the 1s orbital. All right, draw the shape of 1s orbital. So all you have to do is draw the shape of an s orbital, because all the s subshells they are spherical and all the p subshells they are double shaped or bilobed, as we say. Okay, but it doesn't matter if you want to draw 1s, 2s, 3s, any s is spherical and p is always double shaped. There is no third shape that you need to remember. Reduce the number of unpaired electrons in cobalt atom. How many unpaired electrons are there in cobalt atom? For that we have to look at its final shells, right? Because look, how do we know unpaired electrons? If the subshell is not complete, then there is chance of unpaired electron. If the subshell is complete, then that subshell does not have any electrons. This subshell of cobalt does not have electrons. Unpaired, this subshell, this subshell, this subshell, this subshell, even the 4s2 subshell, they are all complete subshells. So none of these subshells have any empty orbital, any empty shells or any unpaired electrons. Now the 3d10, the D subshell has 10 electrons. That is why from you heard 3d10 from me right now, because I mistakenly said 3d10. It says 3d7, right? But 3d7 basically means that it has 7 electrons, right? So let's just make all the d orbitals 1, 2, 3, 4, and 5. I think we have 5, right? Yeah, so we have 5. Just use the size from this side. Okay, so 7 electrons. If you want to do 7 electrons, you do it like this: 1, 2, 3, 4, 5, 6, 7. So how many empty are there, or how many unpaired are there? These are all unpaired electrons, right? So how many unpaired electrons are there? 3. You did not have to do this much rocket science. This is for understanding and me explaining. All you needed to do was look at D. D has 7 electrons. That means 5 of its subshells have 5 electrons each, and then 2 of its subshells have 1 more electron, meaning 2 subshells are complete and 3 subshells are half filled. So 3 unpaired electrons, right? Next question. Next question. Table 1.1 gives some details of stable naturally occurring isotopes of rhodium and iridium. 10345 RH, 19177 IR, 19377 IR. Number of neutrons 58, number of electrons, वगैरह वगैरह. This is a very easy question. We had to say the number of protons, but the number of protons are the atomic number. All right, there is nothing much to it. I mean, this is what you have to write over here. Similarly, 77 is what you will write over here, and 77 is what you will write over here as well. Okay. All right. I hope that makes sense. Now, the next thing we want to do is, we want to do number of neutrons. All right. We want to do number of neutrons. How do we do number of neutrons? Let's look. 45 minus 103 gives us number of neutrons, meaning atomic number minus atomic mass. All right. So similarly, 191 minus 77. Can anyone tell me what that would be? What is 191 minus 77? I do not happen to have a calculator today. What is 191 minus 77?
114.
114, 114. And what is 193 minus 77? So it's like two more, so it should be 116. Just two more neutrons, right? Because 191, then 193. All right. Total number of electron shells for these guys, there were six. For total number of electron shells in rhodium, there are multiple ways to do it. What you can do is go down here, keep going down, keep going down, keep going down, and look where rhodium is. The symbol of rhodium was, what was the symbol of rhodium? RH, right? Yeah, right here. This is rhodium. Okay. So which period is it in? One, two, three, four, and rhodium is in the fifth period. So total number of shells that it should have are five. You do not have to write its electronic configuration. You might get stuck trying to write its electronic configuration. Instead, just go about and write how many shells it has. There's not It's not too difficult. All right, just look at the number of periods and write it down. That would make you do it. Next question. Table 1.2 shows the relative abundances of isotopes in a sample of an alloy containing rhodium and iridium only. All right. So we want to tell how much sample of alloy there is in rhodium and iridium. All right. Relative abundance of 103.45 rhodium is 50. All right, that means 50%, by the way. All right, 191 is 15.18 and 193 IR is 34.82. Define relative isotopic mass. All right, so how do you explain relative? Relative basically means compared to isotopic mass of an isotope, right? So mass of an isotope of an element, we want to use the word compared to the mass, compared to 1/12 of, ऐसे कर लो, 1/12 of mass of a carbon 12 isotope. It's a better sentence structure. All right, so this is how you do it. Next, use table 1.2 to calculate the relative atomic mass AR of iridium in the alloy. Give your answer to two decimal places. So the alloy contains relative atomic mass of iridium in the alloy. Give your answer to two decimal places. All right. So we know that 50% of the alloy is rhodium, meaning 50% of the alloy constitutes of this mass. But they are asking use table 1.2 to calculate relative atomic mass AR of iridium in the alloy. So in the alloy, only 50% of the alloy is iridium, as you can see, right? Only 50% of the alloy is iridium. And now out of the 50%, 15.18 is 191 iridium and 34.82 is 193 iridium. If you total these two, it should give you 50. That is what I believe. ठीक है, सही है. So the formula is atomic mass AR is equals to bracket percentage abundance multiply by the IR, right? Relative atomic mass. And we have to do summation of however many isotopes we have divided by. Now, in this case, we will write 50. Why? Because, beta, as I have explained you before as well, there are several cases. Like sometimes you are given the condition like this, that, for example, a substance contains 2412 magnesium and 2612 magnesium, these two isotopes. I don't even know this isotope exists or not. I'm just giving you a scenario. And they are in the ratio of 4:5. Calculate the AR. Now, you can go ahead, sit there and try and find the percentage of magnesium according to this ratio and the percentage of magnesium 26 according to this ratio. Or you could just do summation ratio multiply by IR divided by 9 because the total parts of ratio are 9. Similarly, over here, you can take this as a ratio. Okay, bhai, 191 IR is 15.18 and 192.96 IR is 34.82. ठीक है, सही है. तो you can divide the two of them. You can divide the two of them this way, and then you can consider them the ratio, and therefore the denominator becomes 50. All right. So now over here, the denominator will not be more than 50. The denominator will only be 50, and now we will make two brackets. One bracket will we will make of the where did it go? The 15.18 190.96 ala isotope. So 15.18 multiplied by 190.96 plus bracket. The second one is 34.82 multiplied by 192.96 and divided by 50. All right. So beta, I need the complete answer to it. Can you guys give me the complete answer? I'll go collect, just go get my calculator. Till then, just one second. All right. Did you guys find the answer to it?
192.4.
192.4. If you put everything in the calculator, you should get an answer. So if you're saying it's 192.4, then it should be, and it sounds correct because look, how do I know? How could I know that it sounds correct? Look, this is 7:3 ka ratio technically if you look at it, because 35 is to 15, that is 3 times and 7 times. So it's 70% closer to this one. So the answer should be closer to 192 than it should be to 190, which we can see it happening over here. All right. Anyways, so let me just erase this thing down below. This is for understanding, beta. If you are given ratio, then you can use the ratios, but just know that denominator will be equal to whatever the total ratio parts equal to. Okay. Next question is hydrated rhodium to 3 chloride RHCl3.XH2 catalyzes the conversion of ethene to butene. All right. Both stereoisomers of butene are formed in the reaction. Hydrated rhodium 2 chloride contains 20%, 20.5% by mass of water of crystallization. Reduce the integer value of X in RHCl3. All right. Hydrated rhodium 3 chloride contains 20.5% mass of water of crystallization. That means that if I subtract RHCl3 and I do ratio H2O, right? X moles of H2O. So this is 20.5%. So naturally, the other side is 100 minus 20.5, right? Which is equals to 79.5. For the betterment of our situation, right? To make our lives easier, we can just, for now, we can do 80-20 ratio, right? 80-20 ratio. Now, questions like these, you can solve them in a lot of ways. You can solve them in a lot of ways. Like, for example, I could do another way. Like, I could make another equation over here as well. I could say that how did they come up to find that rhodium chloride contains 20% by mass of water of crystallization, because they must have said this in a sentence. 20%, let's suppose 20% of RHCl3, right? Rhodium chloride is RHCl3 dot XH2O is water, right? So we can say that 20 upon 100 multiply by MR of whatever this guy is, okay, is equals to X amounts of water, and water is 18. So 18, right? We could do it both ways. All right. Um, and then we do 20 upon 100 multiplied by mr. So we don't really know the mr and we don't know the x. So this is why this equation gets a little tricky. This is why this equation gets a little tricky because we don't know the mr of RHCl3 dot XH2, right? So further solving this would become almost impossible. So that is why I did not choose this initially. What I did choose was, let's use ratios. All right. So we can say that whatever the mass of RHCl3 is 80%, and whatever the mass of XH2 is 20%. So what is the mass of MR of RHCl3? All right. So MR of RHCl3, how can we calculate that? We can find that out by looking at the periodic table. RH is was in the fifth period. RH has a mass of 102.9. For our easiness, we can even consider it 103. We can even consider it 103. And Cl is 35.5. So we can consider it 35.5. Okay. So RH is 103 and Cl can be 35.5. Let's continue. So this is RH is 103 plus 3 multiplied by 35.5 equals to 35.5 times 3 plus 103 equals to 209.5. So the mass of RHCl3 is 209.5. ठीक है, सही है? अच्छा. All right. So we now know that 209.5 is the 80%. 209.5 is roughly equal to 80% or 79%. So let's just take it absolute 79.5%. So how much mass would be equal to 20.5%? Right? So we'll just cross multiply now. We'll just cross multiply. So x is equals to 209.5 multiplied by 20.5 divided by 79.5. So let's do multiply by 20.5 divided by 79.5 equals to 2D. So the answer we are getting is 54.02. 54.02. ठीक है, सही है. तो we can say that mass of X H2O is 54.02. So H2O, so value of X is 54.02 divided by mr of water, which is 18. This divided by 18, we get 3.001, which is equal to 3. So the value of X in this situation is 3. So this means that this was only a mathematical question. This was only a mathematical question. All right. This was a mathematical question. A mathematical question means you had to use maths. So when you remove water, you remove 20.5% of the mass. So what is the mass of RHCl3? It is equivalent to roughly 80. So we found out the mass of RHCl3 was roughly 80. So what would be the mass of water in it, which was 20? So we just do a unitary method situation. And once we do unitary method, we found out that 20% should be equivalent to roughly 54 mass. How many moles of water are required to equal 54 mass? 3 moles, because uh, one mole is 18 mass, right? 1 mole of water is mass 18. Yeah, I hope that makes sense. Just give me a moment, please. I have to make space for the question at the bottom. All right. The next question says define stereoisomers. Now, stereoisomers, we do not say compounds having same structural formula but different molecular formula, something like that. We don't say that. What do we say instead? We say that stereoisomers are compounds having same um, molecular formula but different arrangement of atoms in space. All right, same molecular formula and same structure but different arrangement of atoms in space. That is the definition of stereoisomers that we want to adopt, that we would like to adopt, that we would like to say. Okay, so we will say compounds having organic compounds having same molecular and structural formula but different arrangement of atoms in space. All right, so basically this is what gets you the 1 mark. Different arrangement of atoms in space. This is a term that is very important for using in stereoisomers. Explain how the conversion of ethene to butene can be described as an addition reaction. How can we convert ethene to butene and we call it an addition reaction? So, I mean, you don't have to think about it too much. It's a common sense question. How can you describe it as an addition reaction? Because a single product is formed. Only a single product is formed. If in exam they ever ask you why something is an addition reaction, you don't have to ask them what thing. Please elaborate what is that something. You have to say only a single product is formed. If something is called an addition reaction, then the first rule of that something is it should be made in such a way that only a single product forms. All right, next question. Draw two stereoisomers of butene. So first of all, we need to know what butene looks like. So butene contains the carbon-carbon double bond on the second and third carbon. That is why it's called butene, meaning one carbon should be on this one, CH3, and one carbon should be on this one, CH3, and then H, and then H, right? Okay, so draw the two stereoisomers of butene. So, well, we have drawn just one, all right? And then we can just duplicate it, take it on the other side, and switch the hydrogen with the CH3, right? Hydrogen here and CH3 over here, all right? This is called cis butene, right? And then this is called trans butene. ठीक है? The next thing, if this question had another word, draw the skeletal formula of the two isomers of butene, then you would have to draw their skeletal formulas. How would you draw their skeletal formulas? You would draw their skeletal formulas. Let me just write this name outside the box because the name was not asked, but the structure was asked. So you can write it like this, okay? Or you could draw their skeletal formula, and their skeletal formula could look like this, and then this. All right, that is all you had to draw. Try making it look almost similar, okay? And then the double bond can be right here to show that it is a double bond. And then for the other one, you just draw like this, and then you take this line and put it over here. This is the other one. So both are drawn. So skeletal formulas look a lot easier. Skeletal formulas, they look a lot easier, but basically students, they are more comfortable in drawing structures. That is why we tend to draw structures as much as possible wherever it is asked. Question number 2. Chlorine is one of the elements in group 17 of the periodic table. Describe the colors of group 7 elements chlorine to iodine at room temperature. Okay, so they want to describe the colors, meaning we just want to say what colors there are. So we say chlorine is yellowish green, bromine is an orange red liquid, while iodine is a blue, or let's say dark blue slash black, or let's not put a slash, say bluish black solid. All right, Next question. Describe the relative reactivity of elements chlorine to iodine as oxidizing agents. As oxidizing agents. So which one is the strongest oxidizing agent? The one that has the highest capability to get reduced itself. So which one has the highest capability to get reduced itself? Chlorine. Why? Because chlorine is most reactive. Chlorine to iodine, chlorine is most reactive. So chlorine is the strongest. Chlorine is strongest oxidizing agent, while iodine is weakest. Next, state what is observed when chlorine reacts with hydrogen. What is observed when chlorine reacts with hydrogen? What is observed when chlorine reacts with hydrogen? It's very simple. Chlorine and hydrogen, when they react, they produce HCl. If you don't know, so H2 plus Cl2, they produce. I don't know if I don't remember if this was the reversible. Well, H2 and I2 is a reversible, but I don't know if H2 and Cl2 is also reversible. But nonetheless, they produce hydrogen chloride gas HCl, and it has a white streamy fume, right? It has a white streamy fume, right? So basically, that is one thing you observe. Okay, when chlorine it reacts with hydrogen, जो a white steamy fume produces. और दूसरी चीज क्या ऑब्जर्व करते हो, दूसरी चीज ऑब्जर्व करते हो कि क्लोरीन का अपना जो येलोइश ग्रीन कलर है वो डिसअपियर होना शुरू हो जाता है, ठीक है। तो वाइट, या फिर यूं लिखो ना, ग्रीन कलर डिसअपियर्स, this APPEARS appears, and white fumes are produced. So green color disappears and white fumes are produced. Explain why the thermal stability of the hydrogen halides decreases down the group. Why do hydrogen halides thermal stability decrease down the group? Because what defines thermal stability? How is something more resistant or more thermally stable? Like, why do we say that sodium chloride does not break down when heated, but other chlorides might? Or sodium carbonate does not break down when heated, but lithium carbonate does. It is all dependent upon the bond strength, right? The stronger the bond, the more chance there is for something to have, you know, to have the strength, right, to be broken down. So if thermal stability of hydrogen halide decreases down the group, that is because the hydrogen halide bond becomes weaker. Okay, as we go down the group, as we go down the group, the hydrogen halide bond becomes weaker and requires less energy to overcome. This is something you have to write. On to the next question. The halogenoalkanes CH3CH2Cl forms when chlorine reacts with C2H6 via a free radical substitution mechanism. So CH3Cl, it forms when chlorine reacts with C2H6 via free radical substitution mechanism. Define free radical. What is a free radical? We have just explained, basically not explained, we have just looked up in the first question, and there was a question related to free radical, but they did not use the word free radical. They had said which how many unpaired electrons are there. Number of unpaired electrons are called free radicals. ठीक है? A species which contains at least one unpaired electron. Okay? A species which contains at least one unpaired electron. Next question. State the essential condition for chlorine to react with C2H6 at room temperature. So what is the essential condition for chlorine to react with C2H6 at room temperature? So you need to know that if C2H6 wants to react with chlorine, this is what we call a nucleophilic, sorry, this is what we call a electrophilic substitution reaction. Sorry, what did I say? Electrophilic. A free radical substitution reaction, right? This is called a free radical substitution reaction and it requires UV light. What does it require, beta? It requires UV light. Next question. Write two equations to show the propagation steps in this reaction. We want to show propagation step. Propagation step is in which a free radical, like for example CH3 free radical, is reacting with Cl2 and producing CH3Cl plus Cl free radical. That could happen. All right, that could be a propagation step. Or we could say methane is reacting, or is it ethane actually? Oh, in this reaction, so we can't use CH3, we have to use the ethane. Alhamdulillah. We have to use C2H5 free radical, for example, and we have to use let's suppose C2H6 as well. And if this reacts with Cl2, we also see the formation of C2H5 radical and we see the formation of HCl. All right, so these are steps. These are the steps. Okay. Next, CHCl3 is another halogenoalkane. CHCl3 forms when propanol reacts with NaClO. NaClO is made from chlorine in a disproportionation reaction. Identify a reagent and condition that can be used to convert chlorine to NaClO. All right, now here's the thing. There are two things. Chlorine can react with something, and that something is called sodium hydroxide, and it can produce NaClO. But this same reaction, when conditions are tinkered with a little bit, it can produce NaClO3. When does NaClO3 form and when does NaClO form? This is something you have to remember. So please remember, NaClO is formed when we use cold and dilute sodium hydroxide, and NaClO3 is formed when we use hot and concentrated sodium hydroxide. For now, we want to produce NaClO. We want to produce NaClO. So we are going to use cold, dilute, aqueous sodium hydroxide. Sodium hydroxide. Define disproportionation, a reaction in which same species is getting oxidized as well as reduced. Such a chemical reaction is called disproportionation reaction. And in the above equation, we in this one, the formation of NaClO, we do see disproportionation reaction. But let's see what they have to do next. Write numbers in the boxes to balance the equation showing the reaction of propanol with NaClO. So when propanol and NaClO react, they produce CHCl3 and they produce CH3COO Na and they produce NaOH. Okay. 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 So the easier way to do it, the easier way out is to look at this, all right? To look at this and say, okay, there are three chlorines over here, so we should put a three over here. Because we put a three over here, now there are three sodiums on this side, all right? Now we could put because there is one sodium here and one sodium here, that means we can either put a two over here or we can put a two over here, all right? It depends where we want to put the two. It doesn't really matter where we put the two though. Why? Because look, the thing is, you have to understand that you can't put anything other than one over here, because the CH3COO or just CH3CO, this much is only once, and you can't put anything on this side, right? So other than one, you can't put anything over here, so you have to put a two over here and you have to put a one. over here, and this is how you will balance the equation. All right, the reason why when I put the 2 over here, I know I automatically balance because I don't have any other moves. And if I count, sodiums are balanced, chlorines are balanced, carbons are balanced, 3 carbons on this side, 3 carbons on this side. All right, hydrogens are balanced, 6 hydrogens over here. All right, and 1 2 3 4 5 6, because twice, right? 6 hydrogens over here. All right, and oxygens 1 and 3, 4 oxygens, and on this side 2 oxygens and 2 oxygens, 4 oxygens. Everything is balanced. Okay. Next question. Aqueous AgNO3 dissolved in ethanol reacts with aqueous solution of CHCl3. All right. When CHCl3 is reacted with aqueous silver nitrate because it contains Cl3, what shall we see? What shall we see? So state what is observed in this reaction. Explain your answer. We want to explain our answer as well. So right. So what is observed? A white precipitate. फॉर्मेशन ऑफ अ व्हाइट प्रेसिपिटेट इज ऑब्जर्व्ड, इस तरह से लिख लेते हैं. फॉर्मेशन ऑफ अ व्हाइट formation of a white precipitate is full stop. This is because the silver ions and chloride ions react to form silver 1 chloride, which is an insoluble ionic compound. All right. So this is how you want to explain that. I mean, there was nothing much in it. Question number 3. The group 14 elements show a change from non-metallic to metallic character down the group. All right. Table 3.1 shows some properties of the two group 14 elements, carbon and SN, in their standard state. The table is incomplete. Graphite, they want to talk about graphite. Does it conduct electrical conductivity? Yes, it does. It is a good conductor. All right. What type of bonding it has? It has covalent bonding better. All right. What type of structure does SN have? SN is tin. I believe SN is tin, right? And because it is tin, it is metallic. It should have a giant metallic lattice structure as well, right? It should have a giant metallic lattice structure. 3 marks for such easy question. Next, identify the lattice structure shown by graphite. It has a giant covalent lattice structure, but I think they want us to tell the shape as well, right? So we will say hexagonal shaped giant. I mean, haven't they just told us over here though? Why have they asked us this question? This is why it makes it confusing. Hexagonal shaped giant covalent. If I say covalent and I wrote covalent and giant both words over here, that would make it a little difficult for the examiner. I mean, examiners don't really repeat questions. So we could use the other word, other than covalent, we can use the word molecular. Giant molecular lattice, hexagonal shaped giant molecular lattice. All right, we can say that. Explain why SN has good electrical conductivity, because SN has free flowing electrons. Okay, so it has free flowing electrons in its metallic lattice. Carbon is found in inorganic compounds such as carbonates. Write an equation for reaction of magnesium carbonate with dilute hydrochloric acid. Whenever a metal carbonate reacts with an acid, you should always remember, that should be common practice now. salt produces, which will be magnesium chloride in this case, and carbon dioxide and water produce. All right, this should be common practice now, but I'm repeating. The way you balance the equation is by putting a 2 over here, and the equation is balanced. All right, two hydrogens, two chlorines, one magnesium, one carbon, three oxygens, 2 plus 1, three oxygens. All right, describe the thermal stability of carbonates down group 2. So what happens to thermal stability? As we go down the group, reactivity increases, therefore bond strength will increase, therefore thermal stability will increase. All right, so thermal stability increases down the group. All right, thermal stability increases down the group. Next question, ammonium carbonate undergoes an acid base reaction with sodium hydroxide. Explain this statement. All right, ammonium carbonate undergoes an acid base reaction with sodium hydroxide. Explain this statement. Like, why does ammonium carbonate undergo an acid base reaction? Um, because ammonium carbonate acts as a base over here. All right. So we want to say, okay, uh, sorry, over here, because sodium hydroxide is the base, we want to explain why ammonium carbonate could react with sodium hydroxide, which is kind of like an alkali. So this sodium carbonate is a strong alkali, so this ammonium must be an acid. So in your syllabus, in nitrogen compounds, we have studied that ammonium and ammonia, right? Two guys, NH3 and NH4 positive, right? Two guys, ammonia and ammonia. Ammonia is considered a base because it has a lone pair which attracts protons. So it is a proton acceptor. And ammonium carbonate is considered an acid because it has no lone pair and a weak dative bond which has an H positive ion connected, right? So this H positive ion, it gives away under dire situations, right? So under severe circumstances, when there are strong reactive agents which are looking for protons, and alkali, the stronger the alkali, the stronger its proton accepting ability is. So sodium hydroxide would look at ammonium and say, "Hey, why the heck do you have a hydrogen when I am the stronger alkali?" And it will snatch that hydrogen away. That is why in ammonium compounds, whenever you add sodium hydroxide and you heat, ammonia gas is produced because the hydrogen is snatched, making ammonia, and then that gas is produced. That is also a chemical test for ammonium ion. All right. So we will say that ammonium NH4 plus ion contains an additional proton H positive ion that is held weakly. This proton is donated in presence of strong alkali, strong alkali such as strong alkali such as NaOH. Full stop. Hence, NH4 plus acts as proton donor, यानी के acid. And which kind of acid? If you want to define how, if it is a proton donor, is it going to be called an acid? Because Bronsted-Lowry theory states that. You have to know that this was the statement given by Bronsted-Lowry. Figure 3.1 shows a sketch of some of the ionization energies of silicon Si. Alright, complete the graph in figure 3.1 to show the third to sixth ionization energy of Si. Alright, third, fourth, and fifth are not drawn. The reason why is because they want us to be smart. So third ionization energy should require more energy than the second, and fourth ionization energy should require more energy than the third, right? But silicon only has 4 electrons in its outer shell. Then it has the next electrons in its inner shell. And because it has the next electron in its inner shell, the jump should become drastic. The jump should become drastic. So there should be a very long jump over here. All right. And then sixth as well, we have to draw because sixth is not here. So this is the drastic jump. And then this is the jump for six. All right. So then these guys increase in a certain set and these guys increase in a certain set, and then there's a large jump. All right. So this jump you had to show. Next, construct an equation to show the second ionization energy of Si. Second ionization energy means Si has already lost an electron. Therefore, it has a +1 charge. It should be gaseous. All right. And then second ionization energy would make it lose its second electron. So +2 gaseous plus electron. All right. This is how you write the second ionization energy. Okay. Next question. Figure 3.2 shows the boiling point of the simplest hydrides of group 14 elements, carbon to lead. All right. Carbon to lead boiling point is definitely increasing as we can see. So we can say that bond strength is becoming stronger. Explain the trend in boiling points in the group 14 hydrides shown in figure 3.2, and it's a 2 mark question. So it's very simple. Um, the boiling point is increasing. First of all, that is the trend. Boiling point of group 14 hydrides is increasing down the group. Full stop. This is because as we go down the group, the atoms have greater number of electrons. Hence, the electrostatic forces of attraction increase. All right, reduce the shape of molecule of Si. Si is a molecule that has 4 hydrogens, right? SiH4, and it has no lone pair. So that means it has tetrahedral geometry. All right, tetrahedral geometry. Next question. Silicon readily reacts with elements of high electronegativity. Write an equation for the formation of SiCl4 from its constituent elements. So SiCl4, we want to write its equation from its constituent elements. So silicon plus 2 moles of chlorine should give us SiCl4. This should be our equation. I think that is what they were asking. Describe what is observed when a small sample of SiCl4 is added to water. A trend that we should remember. Beta, whether it is SiCl4, whether it is even Al2Cl6, all right, it is all written in your group 17 wala chapter, ठीक है? Or is it written in periodicity wala chapter? Let me just confirm. I think it was written in the first one, the periodicity wala chapter, all right? Yeah, right here. Look, whether it is aluminum chloride, silicon chloride, phosphorus, yeah, sulfur. All right, Al2Cl6, SiCl4, PCl5, or SCl6. The same thing is observed that white fumes of hydrogen chloride are produced. White fumes of hydrogen chloride are produced. This is a fixed thing that you have to remember, that you have to say every single time. All right, so we say white fumes of hydrogen chloride. White. Why is that happening? White fumes of hydrogen chloride gas are produced. Next question. SiO2 is a white solid that melts above 1700 degrees Celsius. SiCl4 is a colorless liquid at room temperature. Explain the difference in melting points of these two compounds with reference to their structure and bonding. All right, silicon dioxide has a high melting point and silicon chloride is liquid, meaning it has a low melting point. All right, so we are going to say that SiO2 has a giant covalent lattice structure with very strong intermolecular forces of attraction. Full stop. Meanwhile, SiCl4 is a simple molecular compound with no polarity. ये भी लिख लो, no polarity. Stop. Hence, it only has London dispersion forces between its molecules. So this is a very well explained answer. ठीक है, तो इस तरीके से आपको लिखना होगा. ठीक है, तो लंदन डिस्पर्जन फोर्सेस की जगह आप इंड्यूस्ड डायपोल इंस्टेंटेनियस डायपोल भी लिख सकते थे. दैट इज आल्सो अ वर्ड दैट यू कैन यूज. सो लंदन डिस्पर्जन फोर्सेस इज आल्सो कॉल्ड इंड्यूस्ड डायपोल इंस्टेंटेनियस डायपोल और द अदर वे अराउंड, इंस्टेंटेनियस डायपोल इंड्यूस्ड डायपोल. ऑलराइट, नेक्स्ट क्वेश्चन. Tin forms an amphoteric oxide SnO2. Suggests the formula of tin compound that forms when SnO2 reacts with H2SO4 in an acid-base reaction. So, what would be the formula of SnO2? Suggest the formula of tin compound that forms when SnO2 reacts with H2SO4. All right. Because tin is an amphoteric oxide, that means it acts as a base and it acts as an acid. Now, what is the oxidation state of, because they want to ask us the compound salt, what would it form? So right now I can write the word equation, which is easy. Tin oxide plus sulfuric acid, because right now it is reacting with an acid, it acts as a base and it should produce the salt tin sulfate. All right, and it should produce water. They are asking what is the formula of this tin sulfate. We want to know the formula of tin sulfate. All right, so how would you know the formula of tin sulfate? You need to know the oxidation state. If something is SnO2, that means Sn has a charge of +4 and sulfate has a charge of -2, if you remember, right? So 4 goes here, 2 goes here. Simplification ke baad it becomes SnSO4 whole twice. That is how you write this formula now, right? I can show it right here. Sn2 SO4 whole 4, and we simplify it by cancelling these two and it becomes SnSO4 whole twice. Okay, next question. Propanone CH3COCH3 is an important organic reagent. Figure 4.1 shows some reactions of propanone and its derivatives. Propanone, KCN and HCN, reaction 1, and it produces A. All right. Ketone, when reacted with KCN and HCN, it produces hydroxynitriles. Hydroxynitriles. Then in reaction 2, the nitrile is converted into the carboxylic acid. That is also something that is possible. All right. Then directly propanone can also be converted into a secondary alcohol, that is reduction, as you can see. And propanone also reacts with 2,4-DNPH to produce products which we do not need to know. We just need to know the color that is formed, and that is what they're going to ask us as well. Anyways, let's have a look at the first question. Reaction one is nucleophilic addition reaction. Yes, so we want to do the charges, partial polarity. So this is partial positive, this is partial negative. This is a very, 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 very standard situation that takes place. All right, and then we see this and then we see one bond going to oxide. So we see H3C carbon oxide with a lone pair and a negative charge. All right, and carbon is joined with a Cn and it's joined with a CH3. There needs to be an H positive around somewhere so that this guy can donate it, so that the OH and everything can form. Okay, so this is the whole mechanism arrows you had to draw. It is a very easy way to show it, beta. There is no problem in it. You should learn how to write the polarities, the partial polarities. Explain why A does not show optical isomerism. Why does option A does not show optical isomerism? A does not show optical isomerism because it does not have a chiral center. The carbon is joined to the same groups. All right. So A does not show chiral center because the carbon atom is not bonded to four different groups. All right. So in A, the central carbon is not joined to four different groups. ठीक है. Next question. Suggest the reagents and conditions for reaction 2. What is reaction 2? Reaction 2 is when the cyanide converts into carboxylic acid. All right, when the cyanide converts into carboxylic acid. So, how do you convert a cyanide into carboxylic acid? You should remember it is the hydrolysis in presence of an acid. This reaction is called hydrolysis in presence of an acid. Hydrolysis in presence of an acid, basically meaning you can just add an aqueous acid. Like for example, I can add AQUEOUS, aqueous. In the notes it says aqueous hydrogen chloride, so aqueous HCl. All right, you can use aqueous HCl and it will produce the same situation. All right, next, reaction 3 is reduction. Construct an equation to represent reaction 3. All right, so we want to construct an equation to represent reaction 3. What is reaction 3? Reaction 3 produces the alcohol. All right, so we want to call this CH3 COCH3 plus H it produces. And you should know that we also need water molecule. I believe we need a water molecule as well. Or do we not need a water molecule? We just need this and arrow. Let me just confirm. So we get CH3 CHOH CH3. Is it enough? Let's see. So this carbon now has two hydrogens because one bond is broken, so it needs one hydrogen at the bottom, and then this oxygen gives the other hydrogen. Yeah, I think this is completely balanced. This seems to be completely balanced. Okay, so this is how you had to write it down. Next, name C. What is C? Oh, C. C is now called 2 propane to all, right? C is called propane to all. Propane to all, right? State what is observed in reaction 4 because there was a carbonyl carbon. Because there was a carbonyl carbon. This is called a carbonyl carbon, right? The product should be orange PPT, right? Orange red भी कहते हैं, खाली orange भी कह सकते हैं, ठीक है? तो an orange precipitate will be observed. ठीक है भाई. तो explain why Felling's reagent does not react with propanol. Good question. ठीक है, देखें, उन्होंने ये पूछा है कि Felling's reagent propanol से react क्यों नहीं करता. ये नहीं पूछा कि Felling's reagent को propanol में डालेंगे तो क्या observation होगा. कोई observation नहीं होगी because Felling's reagent gives positive test in only aldehydes, not in ketones. So once you confirm the presence of carbonyl carbon, you do a Felling's test and you confirm whether it is propanol or propanol, basically a ketone or an aldehyde, on the basis of positive or negative result. If a orange precipitate is observed, and the Fellings reagent is added and no change takes place, then the substance is a ketone. But if you see an orange precipitate because of 2,4-dinitrophenyl hydrazine DNPH, okay, and then the Fellings reagent also gives a reddish color from blue to red, all right. If that happens, then we say aldehyde was present. Now, why does Fellings reagent react with aldehyde and why does it not react with propanol? The reason is Fellings reagent is an oxidizing agent and aldehydes get oxidized, but ketones do not get oxidized, right? So propanol is a ketone, hence it cannot get oxidized. It cannot get oxidized, right? Propanol is a ketone, hence it cannot get oxidized. All right, next question. Compound A, B, and C can be distinguished using infrared spectroscopy. All right, A, B, and C can be distinguished using infrared spectroscopy. All right, what would be the one thing that you would observe in B which would not be in A and C? What would you observe in A that would not be in B and C? And what would you observe in C that would not be in B and A? Basically, you would observe nothing other than alcohol in C, but then in this you will observe alcohol and then you will observe whatever carboxylic acid group gives and whatever this guy gives and whatever. Okay. So figure 4.3 shows infrared spectrum of one of the compounds, and one of the compounds infrared spectrum is shown. All right, and we want to identify, of course we are going to identify, explain why the absorption at 2850 to 2950 are not useful to help determine which of the compound A, B, or C produces the infrared spectrum in 4.3. Because 2850 to 2890, as you can see, is the carbon hydrogen bond, and all three compounds have the carbon hydrogen bond. Okay, this absorption confirms the carbon hydrogen bond, but all three compounds have the carbon hydrogen bonds. Why do I put the have carbon hydrogen bonds? All right, that is the first thing. All right, next, identify which of the compounds A, B, or C produces the infrared spectrum of 4.3. Explain your answer. All right, so when I look at it, you need to know a few things. B contains the OH functional group, meaning B should have the OH bond. All right. B should also contain the carboxylic acid functional group, meaning the COO bond, the CO bond, and the OH bond. So B should contain this. B should contain this. B should contain this bond. But our famous bonds that I always make you remember are the carbon double bond oxygen, which is at around 1750 to 1850, right? And the OH bond, which is of course in every single one of them. So we don't really have to differentiate on the basis of OH, right? So this will have a peak at 1750 to 1850. This will not have a peak at 1750 to 1850. This will not have a peak at 1750 to 1850. All right. And then the next thing, what is also different in this one, in A, is that it contains the carbon triple bond nitrogen bond. Now we do not know this bond frequency की value, right? The wave number, but it gives us, it is 2200 to 2250. All right, it gives us at 2200 to 2250. All right, so that means this is present a frequency of 20 oops a frequency of 2200 to 2250 will only be observed in A. It will not be observed in B. It will not be observed in C because they do not contain the CN bond, right? And then OH will contain neither 200, 2200, neither 1751. All right, now look at the graph. Do we see a peak at 2200 to 2250? The question is, let's look. So there seems to be a peak that is right here. All right, and if I confirm it, this is 2100, this is 2200, this is 2300, right? So that means this value, this peak right here is at 2250, which means that this compound has the carbon triple bond nitrogen functional group. This compound must have the carbon triple bond nitrogen functional group. Confirm it this way as well. 1750 to 1850 is absent. Look, 1750 to 1850 would be right here. This is 1750 and this is 1850. No peak between this value. No peak between this value, meaning the carbonyl functional group is absent. All right. This shows the presence of carbon triple bond nitrogen. This shows the presence of carbon triple bond nitrogen. This shows the presence of carbon triple bond nitrogen. All right. So I did not even put nitrogen. All right. So this means it is confirmed that the compound should be compound A. It contains a peak at absorption ऐसे नहीं कैसे लिख रहे थे यार ऊपर किस तरह लिख रहा है explain why the absorptions at contains a peak. How can we produce the sentence? It's only a matter of sentence. So let's just not use the word sentence. Let's use something else. So it contains a peak. This is actually called wave number. All right. It is called wave number. All right. It contains a peak as at या फिर between the absorption range, between the absorption range of 2200 to 2250, which is characteristic range of the nitrile the C triple bond N. In this equation, in this one, the OH could not help us out because OH was formed in all three compounds. So we couldn't produce or we couldn't really differentiate on the basis of OH. All right. And with that, this past paper is completed. I hope you guys understand. Let me know if you have any question.